Hi, my name is Keisha. My friend Anna just moved to Hawaii. We like to keep in touch by video chatting. When I called her from my house in Texas, the moon was rising. I told her to take a look at the night sky, and she giggled. She had just come home from school. How could that be? Click the highlighted areas to learn more. On the screen, I could see the sun shining in Hawaii. At my house, I could see the moon and stars. Anna thought it was funny that I was in pajamas when she was just getting home from school. Anna and I talked about how things were different in Hawaii. One thing was the same, the moon. We both saw the same moon at night. I told her to look for a full moon when she went to bed that night. I look at the globe and am amazed by how far Hawaii is from Texas. As I look, I spin my globe. It always amazes me to think that Earth moves like this all the time, even if I can't feel it. Welcome to the lesson, How do the sun, Earth, and Moon differ? Where you'll learn more about the sun, Earth, and Moon. The vocabulary words for this lesson are orbit, axis, rotate, and revolve. Click on each word to find out more about it.
Okay, be sure you're writing the vocabulary words down in your science notebook to prepare for the vocabulary test we will have coming up.
Orbit. The path of one object in space around another object. Axis. The imaginary line around which Earth rotates. Rotate. To spin on an axis. Revolve. To go around or orbit another object.
On July 21st, 1969, astronauts Buzz Aldrin and Neil Armstrong became the first humans to walk on the moon. Neil Armstrong said, "That's one small step for a man, one giant leap for mankind." What would it be like to walk on the moon? What would your first words be? Do you like to count the stars or gaze at the moon? If so, you have probably wondered about the sun, the moon, and Earth. There are many ways you can compare Earth and the sun and the moon, including looking at their size, composition, magnetic fields, and atmosphere. Click the images to learn more. Earth is the planet where we live. It feels big to us, but it's one of the smaller planets in the solar system. Does Earth feel solid under your feet? That's because it's a dense and rocky planet. It has a thin atmosphere. Luckily, that atmosphere is just right for us. Earth also has a magnetic field and two magnetic poles. The sun is the closest star to Earth, but it's still 150 million kilometers away. How can we see the sun when it's so far away? Because it's so big. Like other stars, the sun is made up of gases. The sun is surrounded by a large magnetic field that moves like a spiral. You probably know that the moon moves around Earth, but did you know that it is a satellite? The moon is a satellite because it goes around Earth. The moon's orbit is 384,000 kilometers from Earth. Like Earth, the Moon has a dense, rocky structure. The Moon has some weak magnetic fields, but no magnetic poles, and almost no atmosphere. Which one is biggest? Earth, the Moon, or the Sun? You're right. It's the Sun. The Sun is about 1.4 million kilometers in diameter. In comparison, Earth's diameter is 12,756 kilometers, nearly 1/100th as big as the Sun's. That means that 100 Earths would fit across the Sun. How does the Moon compare? At only 3,467 kilometers in diameter, it is much smaller than Earth and the Sun. How else can you compare Earth, the Sun, and the Moon? Think about their composition. The Sun is a fiery ball of gas, while the Moon and Earth are dense and rocky. All three have magnetic fields, although the fields have different shapes and locations. While the Moon has almost no atmosphere, Earth has an atmosphere that supports life. Even though the Sun and the Moon are thousands of kilometers away from Earth, they are very important to us. In fact, Earth, the Sun, and the Moon are all interacting. They are part of a system. Click the images to learn more. You probably know that Earth is part of a solar system. But did you know that the Sun, Earth, and the Moon are a system too? The three bodies move and work together. What holds all the objects in place and helps control their movements? Gravity. Gravity is the force that holds the whole system together. An orbit is the path of one object around another object in space. Can you think of some things that have orbits? Moons and planets have orbits. What keeps these orbits orderly? It's gravity. The pull of gravity keeps most objects in space moving in a predictable way. The Moon has an orbit around Earth. Another way of saying this is to say that the Moon revolves around Earth. When something revolves, it moves in an orbit around something else. While the Moon is revolving around Earth, Earth is moving too. Together, Earth and the Moon revolve around the Sun. The Moon revolves around Earth in a nearly circular elliptical path, while they both revolve around the Sun in a nearly circular elliptical path. The orbits are different in duration. It takes a little less than 28 days for the Moon to revolve around Earth, but it takes about 365 days for Earth to complete its orbit around the Sun. The Sun, Earth, and the Moon are in the same system, but each is unique. Read the statements. Which statements correctly describe the physical characteristics of the Sun, Earth, and the Moon? Click your answers. That's not correct. The Moon and Earth have magnetic fields as well, though the Sun's magnetic field is much stronger than Earth's or the Moon's. Try again. That's not it. The Moon has almost no atmosphere. Try again. That's right. Right. Great work! Comparing size, composition, atmosphere, and magnetic fields helps you see how the Sun, the Moon, and Earth are different. Have you ever seen a sunset? Do you like to watch the sun slowly sink until you can't see it anymore? If you track the sun for part of a day, it appears to move across the sky. Click play to learn more. The sun appears to rise in the east, move across the sky, and set in the west. The moon and stars appear to follow a similar path across the sky. These apparent motions are because Earth rotates. If you spent an evening gazing at the moon, it would appear that the moon rose in the east and moved across the sky to the west. But is the moon really moving across the sky? Or is there something else causing the moon to appear to move? Let's find out. Click the first image to begin. Do you see that line sticking through Earth's poles? That is an imaginary line called an axis. Earth constantly spins around, or rotates, on its axis, and you can't even feel it. Have you ever ridden on a carousel or merry-go-round? As you spin around, you are able to see different things pass by. The objects aren't moving, but you are. It's the same with Earth. As it spins around, your view of the sun, stars, and moon changes. So Earth's rotation is responsible for the apparent movement of the moon, sun, and stars in the sky. It takes approximately 24 hours for Earth to complete a full rotation. Look at the red flag in this animation. What happens to the red flag as Earth spins? In the beginning, the red flag is facing the sun. The people at the red flag have daylight. As Earth spins, the red flag is facing away from the sun. Now it is night. Earth's rotation causes day and night. What would happen if Earth weren't spinning? Instead of waiting 24 hours between sunrises, we would have to wait 365 days for Earth to revolve around the sun and for morning to arrive again. Think about what you've learned about how the sun, the moon, and Earth interact as a system. Is this statement true or false? Earth's rotation on its axis causes it to appear as if the sun, the stars, and the moon move across the sky. Click your answer. That's right. As Earth rotates on its axis, it allows you to have different views of the sun, stars, and moon, causing their apparent movement across the sky. Earth moves in two main ways. Earth's rotation on its axis determines when it is day or night. Earth's revolution determines which season we experience. Let's learn more about the seasons we experience in the United States. Click the yellow dots to learn more about the reason for the seasons. While Earth rotates on its axis, it also revolves around the sun. Did you notice that Earth is slightly tilted on its axis? It's always this way. As Earth rotates, one half of it is oriented toward the sun. The other half is farther away from the sun. The sun's light and energy hit Earth's north and south hemispheres at different angles. Can you find the United States? Look at the angle of the sun's rays hitting the country. What do you notice? The sun's rays are hitting the United States almost directly. This causes more heat from the sun's rays to hit the region. The extra warmth gives us summer. How has the model changed? Did the tilt of the axis change? No, Earth's location changed. How are the sun's rays hitting the United States now? Instead of hitting directly, they are hitting at an angle. At an angle, the sun's rays are less intense. The country is receiving less heat energy, and we experience fall. Earth has been moving again. Find the United States. What do you notice? The country is facing even farther away from the sun. The sun's rays are even less direct. This means that even less light and heat energy reach us. What season do you think the country is experiencing now? That's right. It's winter. Earth has moved again. Can you guess what season it is in the United States? Notice that the country is facing slightly back toward the sun. The sun's rays hit the region at a slight angle. That part of Earth is now receiving more light and heat energy than in winter. You guessed it. The country is experiencing spring. You know that Earth is tilted on its axis. This means that as Earth travels around the sun, a different half, or hemisphere, faces the sun. Why is that important? Because it means that different parts of Earth experience more heat and light energy. Click the images to learn more. Check out the positions of Earth in this picture. What did you notice? In both pictures, one of Earth's poles is tilted more toward the sun than the other. These pictures show a time of the year known as solstice. This is the time in the summer and winter when Earth's axis is tilted most directly toward or away from the sun. During the summer solstice, the hemispheres are getting very different amounts of energy from the sun. The northern hemisphere, including the United States, is facing closer to the sun. Since we receive more light energy, our days are longer. Since we receive more heat energy, our days are warmer. This means that the days are longer, and we have more time to enjoy fun summer activities like swimming and going on picnics. What happens in winter? The opposite is true. During the winter solstice, the sun's rays hit us at an angle. Since we receive less light energy, our days are shorter. And since we receive less heat energy, our days are cooler. Cooler weather is a great excuse to bundle up and have a snowball fight. During the summer and winter solstice, one of the poles is closer to the sun. Look at the image now. What part of Earth is closest to the sun? You're right, the equator. This means that the sun's rays are hitting Earth directly at the equator. The sun's rays are also hitting each hemisphere of Earth equally. This occurs in the spring and fall. These pictures show an equinox. During the spring equinox, the heat and light energy received from the sun are about the same for each hemisphere. The sun's rays aren't hitting us directly, but they aren't at the greatest angle either. Since the poles are again not tilted toward or away from the sun, days and nights are the same length. Heat energy received is also between that of winter and summer. Warmer weather is great for flying kites and going on long walks. During the fall equinox, the northern and southern hemispheres are receiving about the same amount of energy again. Since the poles are not tilted toward or away from the sun, days and nights are equal in length. Heat energy received is also between that of winter and summer. The cooler fall weather is perfect for campfires and hay rides. What's the reason that Earth has seasons? It is because Earth's axis is tilted as the planet makes its orbit around the sun. This also causes the length of day and night to change. Think about each season. Match images of Earth's tilt and relationship to the sun with the season each image shows. Drag a season to begin. What's the reason that Earth has seasons? It is because Earth's axis is tilted as the planet makes its orbit around the sun. This also causes the length of day and night to change. Think about each season. Match images of Earth's tilt and relationship to the sun with the season each image shows. Drag a season to begin.
Okay, guys, so I want you to be aware of what we're looking at here. So first, we're looking at where the sun is in relation to the Earth. or where the Earth is in relation to the sun, because it changes in every picture. Okay, so we have some sun in the bottom, the sun in the top right, sun in the bottom left, and the sun on the top. Okay, now we are also looking at the tilt of the axis, and what we can see here is this green shape up here, that is North America. Okay, that is North America. So it's this in the same place on each of these globes. So North America here, North America here, North America here, and North America here. Okay, so we have to decide by looking at the tilt in the location of the sun, which drawing here represents which season. Okay, so we're going to start with summer. Okay, so this one is not summer, but I picked this one because a lot of students will choose this as summer because they're like, well, the whole thing is lit up. It's all bright. It must be summer, but that's not quite it. We're looking for when the North America part, that's this part up here at the top, is getting the most sunlight. So you can see the sun is far away from North America there. All right, if we go here, we can see that the sun is pretty far away from North America here also. If we go here, look how close it is. North America is tilted towards the sun. Okay, so that one is summer. All right, so then the next one we would be looking for would be winter. I think it's easiest to look for summer and winter first. And if you have a test question like this, it is going to be easiest for you to first identify the summer and the winter, because once you find summer, you know that the winter is going to be the opposite of the summer. So, what looks the opposite of summer? Where is the Earth the furthest from the sun? So that's what we're looking at. When is North America the furthest from the sun? Oops, thought that was okay. All right, these pictures are a little confusing, but here we go. So it's tilted away from the sun. Okay, away from the sun. So one of these is fall, and one of these is spring. All right, so we're looking for North America to be closer. When it's closer, it's moving, in fall, it's moving closer to winter. And when it's spring, it's moving closer to summer. Okay, so fall, and notice where the sun is here. And if we look, the opposite would be spring here.
That's right. We can't feel them, but the movements of Earth affect our lives every day. They determine when the sun comes up and how long our day will be. They affect what clothes we put on and bring the changes of the seasons. The moon, sun, and Earth. The moon, sun, and Earth work together in a system. The moon moves around the Earth, and together they revolve around the sun. Look at the image below. Drag the labels into place to describe parts of this system.
Okay, well, this might be kind of tricky. So let's just look at what we have. We have daytime, axis, hemisphere in summer, rotation, and orbit. So when I'm looking at this picture, I know the axis is that imaginary line that the Earth turns on. So I'm going to do that one first. I know that the moon orbits the Earth. Okay. This little arrow down here is telling us that this axis is turning. The axis turning is the rotation. Okay. Now these next ones get a little bit harder to figure out because we're talking about daytime and we're talking about hemisphere in the summer. So this gets really confusing. All right. So here is the sun over here. Okay. So the hemisphere in the sun is North America here, and then we're showing the daytime.
That's right.
Here.
How long does each of these movements take? One full rotation of Earth takes about 24 hours. Earth's rotation is responsible for our day and night cycle. It takes Earth.
Okay, so that it's going to be important for you to know that a rotation is one day, and that's what changes our days and nights.
A year to revolve around the sun.
Okay, so the Earth going around the sun takes a whole year. All right, and that's called a revolution. And Earth takes a year to move around the sun.
The tilt of Earth's axis and this revolution around the sun cause the seasons. They also cause changes in the length of day and night in some places on Earth. That's a lot of moving and changing. Form a system. Explain how the interaction between Earth and the sun produces day and night. How does this also produce our seasons? Type your answer. Then click OK. One rotation of Earth takes about 24 hours. Earth's rotation is responsible for the length of the day and night. The unique tilt of Earth's axis and its revolution around the sun cause the seasons. You've learned a lot about how the sun, Earth, and the moon differ. Let's review the main ideas from the lesson. The sun, Earth, and the moon have unique physical characteristics that include their size, composition, magnetic fields, and atmosphere. Because the sun, Earth, and the moon move and interact with each other, they make up a system in space. The objects in the system are held in place by gravity. Earth rotates completely on its axis approximately every 24 hours to cause the day-night cycle. Earth's rotation also causes the apparent movement of the sun across the sky. Earth's revolution around the sun and its tilt on its axis are the reasons for seasons. The amount of solar energy reaching each part of Earth varies with the time of day and the season. At times, the sun's rays hit parts of Earth directly, giving those places more heat and light. At other times, the sun's rays hit at an angle, causing that part of Earth to receive less heat and light energy. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
Okay, guys, make sure you go and do your quizzes comprehension check, and I will see you soon. Have a great day.